Alright, so methanol burns in air according to this equation. 3 moles of methanol which burns in presence of 3 moles of oxygen. It produces 2 moles of CO2 and 4 moles of H2O. Alright, so now we need to find 209 grams of methanol. It's used in combustion, and what's the mass of water produced? So we are finding the relationship between methanol and water. Okay, here 2 moles and 4 moles. So first we can find out mole ratio. And mole ratio from this balance equation, we have 4 moles oxygen, 4 moles of H2O, alright, because that's the quantity that we need to find, and we have 2 moles of methanol. Okay, so that's the mole ratio we are using from this balance equation. And before that we just check that is this a balance equation? Yes, this is a balance equation, right? So now we need to convert from 209 grams methanol to moles of methanol. Alright, so let's go to the next slide. We have 209 grams of methanol, CH3OH. We convert into moles of methanol. We know that 1 mole of methanol, this is a molar mass of methanol, which is 32 grams of methanol. So when we do that, grams of methanol cancels, and we got moles of methanol. Now we are using desired mole ratio. Desired mole ratio, we have 4 mole H2O. Remember from balance equation that we use. 2 moles of CH3OH. When you do that, moles of methanol cancel, you convert into moles of water. And then now we have moles of water, we convert it to grams of water, so which is 18 grams of H2O, and we have 1 mole H2O. In this case, we cancel moles of H2O and we got grams of H2O. Now when you multiply 209 times 4 times 18 divide by 32 and 2, you get about 235 grams of H2O. So we use this one as a mole ratio from balance equation. Let me rewrite this one in mole ratio from balance equation. This one we convert mass of given substance to mole, right? That's mass to mole conversion for methanol. And then in these steps we convert moles of water to mass again, but that's for water. So those steps we worked on it, 3 steps, and that's how we got 235 grams of H2O in this process.